Hello, my name is Iriam Chapa. I am in team number 4 with Lorenza Montalvo, Eugenia Marcos, Ana Cecilia Villarreal, and Juan Pablo Garza. And today we are going to give you a brief explanation of what a definite integral is and an example. Now, integration can be used to find areas, volumes, central points, and many useful things. Now, what is the difference of a normal integration and a definite integral? A definite integral has start and end values. In other words, there are boundaries or limits, meaning you should only focus on the area that is being provided for you to calculate.
To find an area between two functions, you need to set up an equation with a combination of definite integrals of both functions. Finding intersects is important because it enables you to set up two definite integrals to help you find your first region. Neither equation will give you the exact information, but it is helpful. Then you will subtract the second equation, then you evaluate your two integrals.
My name is Ana Ceci, and today I'm going to explain definite integrals, and I'm going to do this problem that is to get the area between the curves of these two functions. So first you need to put the two functions equal so you don't have any y's and you can get the x-intercepts. So you pass everything to the same side. So one intercept is x to the 3 and the other one is x to the minus 2. So now you have to make a table of values of both graphs, so you can graph it. So for this one, you will use the two intercepts, but with -1 and +1 of a number, so you can graph it completely. This one is from x to the second minus 2x, and this one is from 12 minus x to the second power. Okay, so now you can graph. So I'm gonna put this function in red. So you go and now the other function. So now you have this area in common, that it's the area that we are going to get out. I'm Lorenza and I'm gonna keep doing the problem. This function is a shaded, this is the one that's going on the top, so it's going to be shaded. And this one is 12 minus x squared, and then the one in the bottom is going to be x squared minus 2x, the top and bottom. So now the formula that I'm going to use is going to be integral of b a top minus bottom. I'm going to do is with my x's that I got here, the one that's bigger is going to go on the b and the smallest one is going to go on the a. So I'm going to start integrating, and the first one is going to be 3 and -2, and the function that goes on the top is going to be 12 minus x squared, and then it's minus, and then it's going to be x squared minus 2x. So now I can finally start integrating.
So, going to be -2x straight over 3 plus 2x squared over 2 plus 12x.
My 3, I'm going to put my 3 in every x of the equation, and then I'm going to get my answer, and I'm going to do the same thing for -2. I'm going to plug it in all of my x's so I can get an answer, and finally do the subtraction, which is going to be the area of the curve. So 27 minus -14.6667 gives me a total of 41.6667 u squared, and that is my final answer.
In this project, we learned to work with definite integrals. I think that it is an easy subject, but at the same time, it's complicated because it has a lot of steps. They are little steps, but it's really important not to miss a single one, because missing one little step changes the whole problem, and your final answer automatically changes. We also worked in teams. I like these projects because they make you work with different thinking people, and you have to collaborate in teamwork so that together you can come up with the right way of doing the project and efficiently doing it. Thank you.